Hello, this is Professor Stephen Neshiba again, and I'm here to help you through some of the Spartan calculations that we'll be actually doing in class. But I thought it would be, if some of you want to get a leg up on that, you can try this at home first. So this is I brought up the handout for this, the intermolecular forces of organic molecules. Here's the in-class activities that we'll be doing, and the first one is to calculate an equilibrium geometry, and that's what we will start with right now. So you should bring up Spartan if you haven't already, and resume. I assume you're back. What we'll do is we'll bring up what you saved as water. I'm going up to that upper left hand side, and there's the file for water that you probably saved and I saved. I'm making it a little bit bigger so I can see it better. And so there's water. I'm left clicking, moving it around. The calculations I will do here, I go up to the setup menu, calculations, and you notice there's various things that are defaulting on this. The main thing is I don't want to do a Hartree. I don't want you to do a Hartree-Fock calculation. I want you to do something called the semi-empirical calculation. Once you choose that, you say submit, and it says it started, and I hope that at least on my computer here it takes a few seconds, and oh, now it says it's completed. So there we go, and there we have our water. Now nothing shows up here until I ask it to show it what it did, so I'm going to go to display, and the first thing I want to do is see about a dipole moment. And there's the dipole moment it calculated, 1.74 dBs. If I want to display it, I click on that button, and there we go. And as you can see, the dipole moment points from sort of the positive end of water to the negative end of water. Good, and you should do this too, I think. All right, assuming you're back, let's do another display. The second display or calculation that I want you to do, or rather, I guess this is the third, because what you've just done is to analyze for polarity. The third one here is to analyze for regions of accessible positive and negative charge. And the way we do that in Spartan is we go up to this display button, and there's this thing called surfaces. And what I need to do is do something called add. I'm going to add the electrostatic potential map. Now it calculates it, then it comes up with this box, says, do you really want me to show it? So I click on that and close that. All right, so here is my electrostatic potential map. Red regions tells me that there's excess negative charge, and that aligns pretty nicely with what the dipole moment said. And the blue regions, that's where the hydrogens are. That's not enough. There's an excess of positive charge there. And if I want to see sort of into it, you'll notice that if I click on there, there's this box appears. If you click away from it, the box disappears. So I'm going to click on it, and that causes some items to show up here in the lower right. I don't want to see, I kind of want to do a transparent vision of image of this electrostatic potential mapping, and so I can see where the molecule is underneath there. Yep, that's the red part is next to the oxygen. That's good. And now I think the last little bit of this, let's see, is to normalize what's called normalizing the color mapping. And that's the deal here is that the default coloring scheme, it's useful for looking at individual molecules, but if you want to compare one molecule to another, we want to have the same coloring scheme. So the way you do that is make sure that that's clicked on there, that little box, and I will go to display. Now when I bring up this thing called properties, I get a different box, and it was because I put that little box on the image. And you see this property range. I'm going to set that, and I'd like you to set that to -300 to +300. And that will change things a little bit, and you'll see that it changes things, for the other molecules that you look at as well. So that's the main things to get you started on this lab, which we will be doing in class.